Don't you think we're done? Don't you think we're done? Don't you think we're done? Knew that it was true from the way you looked at me. Don't know what to do, what to say to make you leave with me. Make me feel alive. Take my hand and run, let me be the one. Let's just take the dive. Night's only begun, don't you think we're done?
14 years of Eco-Runner Team Delft. We innovated. We won. We broke world records, all with one vision in mind: inspiring the world towards sustainable mobility. This year, we have that same vision.
But a different mission. It is time to rethink, make new dreams, and make them come true. With innovative alternative fuels, we are going outside the box. Eco-Runner 15 is ready to drive the future of mobility.
Welcome everyone to the design presentation of Eco-Runner Team Delft. My name is Bart de Waard and I am the team manager of Eco-Runner 15. And tonight we will be showing you the design that we've been working on for the past 6 months. But I would like to start off tonight by showing you a short video of me in 2005. Now, you might be wondering why I'm showing you this video. Well, when I was busy learning how to walk, there was something special happening here in Delft. Back in 2005, a group of 11 friends came together with a shared dream to build a competition-winning car. And driven by this vision, they spent countless hours working on this car alongside their studies. And the result? The first Eco-Runner. And with their car, they entered the Shell Eco Marathon. And in the Shell Eco Marathon, the car that can drive the furthest on the least amount of fuel, so the most efficient car, wins. In the end, they did not win the race, but that did not stop them. This team, helped by some new members, went on to build the second Eco-Runner, the Eco H2, which became our first hydrogen-powered car. And together they gave it their all to get this car up and running, experimenting with hydrogen-powered fuel cell technology, which was far from mainstream at the time. And in 2008, their hard work paid off. They won that Shell Eco Marathon. After years of sleepless nights, determination, and teamwork, they had finally turned their dream into reality. But the story doesn't end there. Over the years, a total of 14 Eco-Runners have been built, and all with one main mission: to inspire the world towards sustainable mobility. And today, this mission is more urgent than ever, as we are facing a daunting reality. the transport sector is responsible for approximately 25% of global CO2 emissions. And this isn't just another statistic. Mobility is a key driver of climate change and the catastrophic events that come with it. We are already witnessing the consequences. Extreme droughts across Africa, devastating floods in Valencia, and even the uncontrollable wildfires in Los Angeles. And the impact of climate change is not limited to these headline-grabbing disasters. It will also lead to a great increase in everyday health problems for our global population due to air pollution, food insecurity, and many other threats. And the World Economic Forum warns that if we don't act now, this climate crisis will lead to a staggering $12.5 trillion in economic losses and 14.5 million deaths by 2050. And they aren't just numbers. They are lives lost to preventable disasters. Yes, I know this might sound shocking, but here's the good news. This is not inevitable. We have the power to change this narrative. And together, we can build a sustainable future. So, what do we need in order to realize that future? Well, first, we need innovators who are unafraid of exploring uncharted territory. And we need dreams of that sustainable future that inspire us to keep pushing forward. And finally, we need unity in order to tackle these challenges together, combining our diverse strengths and perspectives. And at EcoRunner, we are bringing these elements together. We are a team of 26 students, united by that vision of a sustainable future. But we come from different countries and cultures, and we have different academic backgrounds. And here's something else worth noting. The current team is the first in EcoRunner's history to have the same number of women as men on the team. And together, we are showing that with creativity, determination, and collaboration, we can tackle those challenges standing between us and our sustainable future. And together, we are proving that change is possible. Because if we can do this, then why can't the industry? And look at where that mindset has brought us. We won that Shell Eco Marathon 2 more times. And we set the Guinness World Record for greatest distance driven on a single tank of hydrogen. And just last year, we became the first students to build a fully street-legal hydrogen-powered car. And the recipe for success? A team and a dream. And that recipe has worked for EcoRunner ever since I was like the kid in that video. And fast forward 20 years, and it was up to that same kid and the rest of EcoRunner 15 to carry forward that legacy of making dreams come true. So, this year we dared to dream big. And we decided to embrace that spirit of true experimentation and innovation without the pressures of profit margins or commercial constraints. And we started exploring the idea of creating a fuel-flexible car. That is, a vehicle capable of running on a broad range of fuels. Now, imagine being able to fuel your car with whatever sustainable option is available nearby. This fantasy would be a huge step towards a sustainable future, as fuel flexibility has the potential to accelerate the energy transition. This is because it will reduce our reliance on single fuel types while also opening doors to using existing infrastructure or locally available renewable fuels. And to turn this concept of a fuel-flexible car into a reality, we set ourselves the following goal: to design and build the first ever car powered by an externally fired gas turbine. And this gas turbine technology has the potential to combust different kinds of sustainable fuels, including many different kinds of green carbohydrates or even green hydrogen. And this is what makes our car fuel flexible. And to showcase the potential of our vehicle, we will be driving 400 kilometers on 40 liters of green methanol in June. And this green methanol will be produced using only water, air, and solar energy, making our fuel entirely renewable. And through designing and building this car, we are taking a big step towards more fuel flexibility in the transport sector. And through designing and building this car, we are once again putting ourselves at the front line of innovation. And through designing and building this car, we are paving the way for a future where all kinds of mobility can be both accessible and fully sustainable. So, since August, we have been hard at work achieving a design that will achieve our goal. And tonight, it is finally time to present that design to all of you. We will be taking you through our design and will be explaining how our car uses gas turbine technology in order to drive. And in addition, we'll be elaborating upon all the necessary design adaptations in order for our car to be fully functional. But now, it is time for the big reveal. So, this is what you get when a team with a dream comes together in pursuit of something greater. I am very honored to present to you the design of the EcoRunner 15.
Good evening, everyone. My name is Marnix, and I'm the Chief Engineer of EcoRunner 15. And what a wonderful design we have made, right? You've just seen the first ever car, powered by an externally fired gas turbine. And as the Chief Engineer, I'm extremely proud of our design. Now, I want to take you behind the scenes to show how we transformed an ambitious idea into this design. Over the past few months, we've fully dedicated ourselves in realizing this design, with the ultimate goal of building the first ever car powered by an externally fired gas turbine. Our journey began in August, when we first came together as a team. We started by defining our mission and setting a clear goal: to demonstrate the potential of an integrated gas turbine inside a car. Fast forward 6 months, and here we are tonight, showcasing the result of our hard work, determination, and collaboration. The design of EcoRunner 15. And many of you might be wondering, but Marnix, how do you go from setting an ambitious goal, like you did in August, to creating a complete and detailed design, just as you have right now? Well, that's a good question. Let me give you a crash course on how to build a car powered by an externally fired gas turbine. There are 3 key ingredients that you will need. First, start by assembling a team and putting them together into specialized departments where each person's strengths are utilized. Ensure that everyone understands their responsibilities and knows what to do to achieve a successful design. Let's look at our team, for example. Our team consists of 5 specialized departments. The management department is responsible for overseeing the entire project and making sure the team stays on track to meet its goals. The operation department handles our external communication and our exposure, such as managing our social media, connecting with partners, organizing high school visits or events like tonight, and we're even producing our own podcast, The Eco Rumor, where we talk with experts in the field about sustainable mobility. The Powertrain, Electronics and Process Department designs, builds and tests our externally fired gas turbine, energy conversion and storage systems, electric motors, and all other electrical components inside our car. The Body Department is responsible for designing and building our inner structure and our outer shell. On one hand, making sure it can withstand all loads, while also minimizing the aerodynamic drag. And finally, the Vehicle Dynamic Departments handles all crucial components that are needed for smooth car handling, such as the steering system, the brakes, and the wheels. And all these departments really work together to bring our design to life. The next ingredient that you will need is a roadmap. What steps must be taken to achieve a successful design? For us, this began with setting a clear goal of building the first ever car powered by an externally fired gas turbine. From there, we conducted research to see what components were needed inside a car, identified potential challenges, and explored who could help us along the way. Each answer led to new questions, but at a certain point, we knew how to get to our goal. Next came a lot of brainstorming and sketching concepts. Every potential idea was further refined and analyzed. The most promising concepts were selected, detailed, and improved. This phase involved many iterations, designing, simulating in a computer software, refining the designs, and repeating again and again and again. And once the individual components performed as required, we started putting them together into an assembly. Each step in this process brought us closer to our final destination, a fully functioning design of the first ever car powered by an externally fired gas turbine. And the final essential ingredient is motivation. And of course, plenty of coffee. Luckily, the coffee machines in the Dream Hall have been reliable teammates throughout this whole process. And once you will go through all these steps, you will end up with the finished design, just as we have right now. But what makes our design truly unique? Well, our car uses electric motors to spin its wheels, just like our previous hydrogen-powered cars or battery electric vehicles like Tesla's. However, the electricity for these motors is generated by our externally fired gas turbine. The turbine generates our electricity using hot air coming from a combustion chamber. The benefits of this technology lie in its compatibility with a wide range of sustainable fuels, making our engine more versatile than traditional internal combustion engines. And by making a full flexible car, we're taking a big step towards a future where all forms of mobility can be sustainable. And in the upcoming years, we can maximize the potential of our engine by exploring alternative sustainable fuels. So, both physically and conceptually, our car is built around this engine. And this is the first ever car to have an integrated gas turbine into it. Now, let's take a closer look at the externally fired gas turbine and the powertrain system that powers the EcoRunner 15.
Good evening, everyone. My name is Lodewijk, and I am this year's Chief Powertrain, Electronics and Process, or as we like to call it, the PEP department. As the PEP department, we were tasked with making the EcoRunner 15 drive by integrating an externally fired gas turbine. To achieve this, we not only had to design all of its components, but also had to make sure that the electricity generated would reach the electric motor in our wheels. I will now... I'm aware that these are a lot of difficult terms. However, I will begin with explaining the basics of how our car works. In short, we combust fuel, and in our case, green methanol, to heat the air we draw into our car. This air is then pumped through a turbine, making it rotate. And from this rotation, we generate electricity, much like the dynamos on our bikes that power our lights. This electricity is then converted and delivered to the battery and used by the electric motor in our wheel to get our car moving. Now, this is our externally fired gas turbine. This system is responsible for heating the gas, or in our case, just air, and making the turbine rotate. I will now guide you through the airflow within this engine. We'll start at the top of our car, where the air comes in through the vents. This air then enters the compressor, and here the pressure is increased. This is important as the air can hold a lot more energy at a higher pressure. The air now leaves the compressor and enters the recuperator. In the recuperator, two airflows meet, and one airflow is significantly hotter than the other airflow. The hot airflow transfers its heat to the cold airflow. In our recuperator, the hot airflow is the gas leaving the combustion chamber, and the cold airflow is the compressed air I just mentioned. Now the air has been heated and compressed and moves into the turbine. The air contains a lot of energy at this point, and by spinning the turbine, it converts this thermal energy into rotational mechanical energy. To make this a little clearer, think of a wind turbine. The wind turbine spins as the wind blows through its blades. In our turbine, the blades spin at an incredible speed of 200,000 rotations per minute. That's 100 times faster than your really loud washing machine when it's centrifuging. So, the turbine has converted this thermal energy into rotational mechanical energy. Then, a generator converts this mechanical energy into electrical energy, much like the dynamos on our bikes that I mentioned earlier. The air now leaves the turbine and enters the combustion chamber. Here, the air is mixed with fuel and ignited, resulting in temperatures of up to 1,000 degrees Celsius. As you can imagine, this could pose some serious challenges. That's why we designed our combustion chamber to stay cool, using smart airflow patterns within this combustion chamber. On top of that, we added sensors to continuously monitor the air temperature within this chamber. The air is now very hot, and it again leaves the combustion chamber to enter the recuperator. Here, it warms the incoming compressed air. We designed our gas turbine to be externally fired, to maintain the flexibility of combusting even solid fuels. It means that the combustion only takes place after the air has passed through the turbine. This adds a lot of complexity to our system, but it also opens up the possibility for a wider range of fuels. Now, let's return to the generator, as there is a lot more to discuss there. This generator is where the electricity was being produced from the spinning turbine. This electricity, however, still has certain characteristics which are not yet suitable for the battery. That's why we had to make sure that this electricity coming from the generator is converted into this electricity, which is suitable for the battery. To achieve this, we designed our very own rectifier and converter. And with this system, we achieve a stable 60-volt DC supply capable to enter our battery. This energy of electricity is stored in the battery and used by the electric motor in our wheel to get our car moving. That's how we power our car, but that's not where our responsibilities ended, as we were also responsible for all electric components in the car. One key task for our electronics engineers was to install the sensors necessary to measure temperature, pressure, and rotational speed. This system allows us to, see what's happening inside the car, ensure everything stays safe, and make sure that we can identify threats before they become actual problems. All this data coming from these sensors is processed by a microcontroller, and this microcontroller checks if everything is still operating properly. If anything goes wrong, it is programmed to take action. So, for example, if the turbine temperature gets too high, this microcontroller will sense it and will take action to reduce the fuel flow in the combustion chamber, hereby lowering the temperature back to a safe level. This automatic adjustment is crucial, as it directly impacts the safety of our car, but it also impacts the performance of our car. As you can see, we've been incredibly busy designing the powertrain, electronics, and process of our car. And right now, we're working very, very hard alongside all the other departments to make this design come to life. So now, let's take a look.
Good evening, everyone. My name is Mienke and I'm Chief of the Body Department.
And I'm Jannes, and I'm Chief of the Vehicle Dynamics Department. You've just seen how hard we've been working over the past few weeks to build our car. But alongside the Powertrain, Electronics and Process Department, the Body and Vehicle Dynamics Department have also been putting a lot of work into the design of our car. Because, as we all know, of course, an engine is very important to make a car drive. But you know what's even more crucial? The wheels. As the vehicle dynamics engineers, we are responsible for designing and building the steering, the brakes, the suspension, and the wheels of the car. For the wheels, it is important that we maintain grip on the road while still minimizing rolling resistance. And this year, we also had to integrate the electric motor into the left back wheel of the car. But to make sure that we not only drive, but also drive smoothly, the car needs a suspension system. This system consists of springs that absorb the forces the car experiences while driving. Without the suspension system, the car would not be able to drive smoothly over bumps or uneven surfaces, making the driving experience much less enjoyable, but also potentially causing damage to the car. To ensure that the wheels and suspension system are able to handle the loads they experience while driving, we use simulation software in order to model different kinds of scenarios that the car experiences while driving. With these models, we could adjust our designs in order to ensure that the car will perform reliably when we drive it.
All the forces and loads acting on the car will eventually transfer to the space frame. which is the responsibility of the body department. Our space frame consists of 109 steel rods connected to the wheels. I want to thank Jan Wolf in particular, as he's currently helping us to weld the space frame all together. In previous designs, the shell of the EcoRunner was responsible for carrying its load. However, this year we needed more flexibility in our design due to uncertainties around the engine size. As a result, we decided to use the space frame to bear the loads. To help visualize this, compare the shell of previous EcoRunners to the exoskeleton of a crab. Crabs rely on their shell for structural support, since they don't have a spine. Our EcoRunner uses a supporting space frame to bear the loads. This is similar to how the human skeleton provides structure with a spine. Our EcoRunner uses a space frame, and the space frame has beams with a diameter of 3 centimeters. The walls of these beams are only 2 millimeters thick. The configuration of these beams has been analyzed using computer software, as the vehicle dynamics department did for the wheels and a suspension system. But with an engine, wheels, frame and a suspension system, we still need to be able to steer and stop the car.
Luckily, we have thought about that. We've developed a steering system that minimizes the power required to steer effectively. And by carefully adjusting this, we integrated it so that it works seamlessly together with the suspension and the wheels. This process requires extreme precision, down to the millimeter. If even one of these systems isn't properly aligned, the wheels could be unintentionally pushed into the wrong direction and thus creating unsafe driving conditions. By simulating and fine-tuning every detail, we've ensured a driving experience that is smooth, safe, and stable. Of course, as we all know, a car also needs to be able to stop. Therefore, we equipped the car with disc brakes, which is a disc that spins together with the wheels, and when you apply the brakes, pads clamp onto the disc. Thus creating friction, and with this friction the car slows down. By carefully adjusting the brakes, we've provided the perfect balance of friction, not stopping too abruptly with a light press of the pedal, but still being able to come to a quick halt when driving at maximum speeds. So now we have a frame that we can move, control, and stop safely. But there's still one final thing that we need to complete our car.
To go back to the comparison with humans, while the space frame acts as a skeleton, we also need a skin. That's where the shell comes in. The shell is crucial for reducing aerodynamic drag, helping the car move more smoothly through the air. To optimize the shape of the shell, we used computer simulations. These simulations allowed us to analyze the airflow around the car and make adjustments without needing to physically build and test models in a wind tunnel. As you can see here, they provide detailed calculations on the shell's performance. With this data, we could make changes to improve the design to improve the aerodynamics. But designing the shell wasn't just about aerodynamics. We also had to ensure it could accommodate the engine's dimensions and that it fit perfectly around the frame and the wheels, so that during production we could attach it seamlessly. We also included ventilation openings, not only for air intake, but also to allow cooling airflow, which prevents the gas turbine from overheating. Since the space frame now carries all the loads, we had the freedom to make the shell as sustainable as possible. This year we chose flex fibers instead of the carbon fibers we used in previous designs. Flex is a fast-growing plant, and integrating it into our composite shell makes it durable, while also aligning with our commitment to sustainability.
When the shell is finally placed on top of the frame, the design of the EcoRunner 15 is finished. This car is the result of collaboration across all the different departments, with everyone contributing their expertise. But even though the design is finished, our work isn't done yet, and we still have a lot to accomplish over the coming months. But we are excited to keep pushing forward.
In a world where sustainability is more crucial than ever, innovation is the answer.
At EcoRunner Team Delft, we believe innovation starts with dreaming.
After years of building hydrogen-powered cars,
it is time to pioneer again.
To explore bold ideas.
and drive the future of mobility. We are a team of 26 students.
With different study backgrounds, nationalities and perspectives.
Yet we all share the same dream.
To show the world what is possible when a team with a dream comes together.
In pursuit of something extraordinary.
This year we are daring to dream big.
And we are taking on a bold challenge.
Building the world's first ever car, powered by an externally fired gas turbine.
By applying microgas turbine technology.
We're opening the door to a diverse range of sustainable fuels.
And we will prove the potential of our vehicle.
We're driving 400 kilometers on 40 liters of green methanol.
We are EcoRunner 15.
Together, we're not just building an innovative technology.
Together, we are building a sustainable future.
Tonight, we have shown you the design of the EcoRunner 15. And over the past few months, we have been putting in a lot of work towards this great milestone in our year. So, where do we go from here? As you saw earlier this evening, we have already begun production on many parts for our car. And in the coming months, we will keep on bringing our design to life. And by May, we'll have a fully assembled and driving car. And we really hope to see all of you on Tuesday, May 20th at the Nieuwe Kerk here in Delft, where we will proudly reveal the EcoRunner 15 for the first time. And after that reveal, we'll be preparing and testing our car to achieve its goal, to drive 400 kilometers on 40 liters of green methanol. But before we end our design presentation, I would like to take a moment to highlight what makes a year at EcoRunner truly special. Now look, when you go down a road no one has traveled before, you will inevitably come across some tough challenges. And there were moments when these challenges felt overwhelming. It hasn't always been easy to build the first ever car powered by an externally fired gas turbine. And it also wasn't always easy to build a team from scratch. And it certainly wasn't always easy to do both of these things at the same time. But the key to success lies in pushing through, supporting each other, and always staying focused on that one big dream. And as we stand here tonight presenting our design, I could not be prouder of how the team has managed to do just that. Together, we have overcome setbacks, celebrated breakthroughs, and shared moments of joy that have made it all worthwhile. And along the way, we have become more than just a team. We've grown into a close group of friends, different in many ways, but united by that one shared dream. And beyond the intense design work and sometimes stressful activities, we've also made some time to get to know each other, whether through weekly Friday afternoon drinks, team weekends, or even running a half marathon together. But the joy that comes from working with this team also comes from the countless small moments, the coffee breaks, the team lunches, or the team meetings. We celebrate each other's accomplishments, help each other out when needed, and most importantly, we find reasons to laugh along the way. And it is that team spirit that makes a year at EcoRunner truly unforgettable. Not just because of that car that we're building, but because of the joy that comes from working with so many ambitious, driven, and wonderful people. And that is why I want to take this moment to thank my team for making this year so incredibly special. And there are also a few other important people we need to thank. First and foremost, I want to express our gratitude to our partners. Without the dedication and support of our amazing partners, this project would not be possible. Your expertise, trust, and belief in us enable us to keep on driving the future of mobility. So, on behalf of the entire team, thank you for your invaluable contributions. And I would also like to thank our friends and family for supporting us throughout the year and being the safe haven we can go to whenever we need to recharge. Thank you all for being here tonight and celebrating our design with us. We are looking forward to having a drink with you in the foyer in just a few minutes. But before we officially close and head to the foyer, I would like to invite the entire team to join me here on stage. And please give them the round of applause that they deserve. Now, first of all, the management department. The body department. The Powertrain, Electronics and Process department. The Vehicle Dynamics department. And finally, the Operations department. Now, thank you all for being part of this incredible evening. We are EcoRunner 15, and we are driving the future of mobility. Thank you.